Hey everyone, in this video I will be going over the elimination method for solving systems of linear equations. Our learning target is I can solve a system of two linear equations using the elimination method. Our vocabulary, we have some vocabulary words here. We've got coefficient, elimination method, and scale. So to solve a system of linear equations using the elimination method, our goal is to eliminate one of the variables by combining our two equations. In order to eliminate a variable, we must first pick which variable we want to eliminate. Once we do that, we have to make sure our coefficients, a coefficient is just a number that's sitting right in front of a variable. So we have to make sure our coefficients are the same number with opposite signs. From there we can combine, solve for one variable, then substitute what that variable is equal to into one of our original equations to solve for the other variable. Let's check out a few examples to clear this up. So taking a look at our first example, we've got negative x plus 3y equals negative 2, and 4x minus 3y equals negative 10. So first we must pick a variable to eliminate. It will be in our best interest to choose a variable where our coefficients are the same number, but the signs are different. So taking a look at this right here, we've got two options for a variable to eliminate. We've got our x's and we've got our y's. Okay, we've got no other options, just x's and y's. Okay, so now we're going to take a look at the numbers in front. Okay, we are looking for the same number but opposite signs. So one needs to be plus, one needs to be minus. If that is the case, then we are good to eliminate. So if we take a look at our x's, in our top x we've got a coefficient of negative 1. In our bottom x we've got a coefficient of 4. So those are not the same number with opposite signs. But if we go over to our y, we've got a plus 3 in the top equation, and we've got a minus 3 in the bottom equation. That is very good. That means we can combine these two equations and eliminate our y. So what variable has the same coefficient with different signs? Y has coefficients of positive 3 and negative 3. Okay, as I said before, very good news for us. Because this condition is satisfied, we may combine our equations and proceed with the elimination process. So I've got the same problem written down right here. Okay, so taking a look at our first step in this first box, we can combine the two equations, eliminating the y. So what this looks like is, I like to draw a line underneath my equations. And now, just like your standard addition or subtraction problem, we're just going to combine everything, everything that's stacked on top of each other. So taking a look at our x's, we'll start at our left and we'll work our way to the right. We've got negative x, which is the same thing as negative 1x, and a positive 4x. So what I'm going to do is I'm going to combine. So negative 1x, and because this is positive, I'm going to add 4x. So negative 1 plus 4 is going to be a positive 3x. I've got positive 3y, and because this is a negative 3y down here, I will say 3y minus 3y. Those cancel out, they eliminate. That's why this is called the elimination method. My equal sign, and now I have negative 2, and because I have a negative 10 down bottom, I'm going to subtract 10. So negative 2 minus 10 is going to be negative 12. So at this point right here, you can see that I eliminated my y and I'm only left with an x. So at this point, I can solve for x. So I'll rewrite 3x equals negative 12. Now this should be fairly easy because we just have a one-step equation. So I've got 3 in x. To get the x by itself, I will divide by 3 on both sides. 3's are going to cancel. I am left with x equals negative 12 divided by 3, which is going to be negative 4. Okay, first step done. So now what we're going to do, we're going to go down to our last step here. Since we now know what x is, we need to find y, okay, just like we did with the substitution method. So we can pick one of our original equations, and it doesn't matter which one, similar to substitution, and plug the x value in for x to solve for y. So if we go back up to one of our original equations, okay, it doesn't really matter which one we do. How about we do the bottom one here? Okay, so I'm going to take this negative 4 and I'm going to plug it in for x and see what I get for y. So I'll rewrite my bottom equation. Oh, I believe it was 4x minus 3y equals negative 10. And now I know what x is. I know that x is equal to negative 4. So what I can do is I can take this negative 4 and substitute it in for x into the top equation. So if I rewrite my bottom equation, I will have 4 instead of x. I'll plug in the negative 4. And then I'll go on with the rest of my equation. The minus 3y equals negative 10. At this point I'll simplify. 4 times negative 4 is going to be negative 16. And then I'll bring down the minus 3y and the negative 10, as well as the equal sign. Okay, next step. I need to get rid of this negative 16, so I'll add 16 to both sides. Negative 16 plus 16 will cancel, so I'm left with negative 3y equals negative 10 plus 16, and negative 10 plus 16 is going to be a positive 6. My last step will be to get rid of that negative 3, so I get the y by itself. So I'll divide both sides by negative 3. Negative 3's will cancel on the left side. So if I move over here, because I'm running out of space, I'm left with y equals 6 divided by negative 3, which is negative 2. Okay, so I've solved for x, I've solved for y. So I know that the solution to this system of equations is going to be the point negative 4 for x and negative 2 for y. Okay, so now what we're going to do, we're going to take a look at some more examples. Zoom in a little bit. Okay, awesome. So, number 1, I've got negative 6x plus 9y equals 27, and 6x plus 5y equals negative 13. So first thing I need to do is I need to pick a variable to eliminate. So taking a look at these two equations, I've got x or I've got y that I want to eliminate. If I take a look at my x's, I'm looking for the same number with opposite signs. So for my top x, I have a coefficient of negative 6. In my bottom equation, I have a coefficient of positive 6. So that means I can eliminate x. So negative 6x plus 6x will eliminate. 9y, and because I've got a positive 5y down here, I'll add them. So 9y plus 5y is going to be 14y equals 27. Because this is a negative 13, I'll subtract 13, so 27 minus 13 is also 14. So now I can get that y by itself by dividing both sides by 14. 14 divided by 14 on the left side cancels, so I'm left with y equals 14 divided by 14, which is 1. At this point, I need to pick the top or bottom equation and plug 1 in for y in order to solve for x. So I'm going to do the bottom equation. So if I do the bottom equation, I've got 6x plus 5. Instead of y, I'm plugging in 1, equals negative 13. Now I can simplify. So 6x I'm not going to touch yet. 5 times 1 is going to be positive 5. And then equals negative 13, which I haven't dealt with yet. At this point, I can get rid of this plus 5 by subtracting 5 on both sides. Five minus 5 will cancel out. So on the left side, I'm left with 6x. And on the right side, I have negative 13 minus 5, which is going to be negative 18. My last step will be to get that x by itself by dividing by 6. 6's will cancel out on the left side, so I'm left with x equals negative 18 divided by 6, which is negative 3. So the solution to this system of equations is going to be the point negative 3 for x, 1 for y. I'm going to move on to number 2. Okay, so number 2. First, I need to pick a variable to eliminate, x or y. If I take a look at my x's, I've got positive 8x and negative 8x. Those are the same number with opposite signs, so that means I can immediately start eliminating. 8x minus 8x eliminates. Negative 3y plus 4y is going to be positive 1y, or just y. And 15 minus 12 is going to be 3. So that was pretty easy. Because I was left with 1y, I don't need to divide or do any further steps. I've got the y by itself. I know it equals 3, so I'm all set. So now I need to pick the top or bottom equation, plug 3 in for y, and solve for x. I'm going to do the top equation this time. So I would have 8x minus 3. Instead of y, I'm going to plug in positive 3 because I just found that, equals 15. If I simplify, I have 8x. Negative 3 times 3 is going to be negative 9. And then equals 15. At this point, I can get rid of the negative 9 by adding 9 on both sides. When I do that, negative 9 plus 9 on the left side will cancel out. So I am left with 8x equals 15 plus 9, which is 24. From here, I can divide both sides by 8. In order to get the x by itself, 8's will cancel on the left side. So I end up with x equals 24 divided by 8, which is 3. So the solution to this system of equations is going to be the point 3, 3. If you were to graph these, this is the point where they would cross. Okay, I'm going to move down to number 3. Almost halfway there. I've got negative 7x plus 10y equals negative 26, and 7x minus 9y equals 29. So I need to pick a variable to eliminate, x or y. If I take a look at my x's, they are the same number with different signs, which means I can eliminate. Negative 7x plus 7x is gone. 10y minus 9y is going to be positive 1y, or just y, my equal sign, and negative 26 plus 29 is going to be positive 3. So similar to the last problem, I've got no coefficient in front of my y, or I do, but it's 1, so I don't have to divide by anything. I've already got the y by itself. So now I need to pick the top or bottom equation and plug 3 in for y. I'll do the bottom this time. So for my bottom equation, I have 7x minus 9. Instead of y, I'm going to plug in that 3 that I just found. It's no longer an unknown. Equals 29. If I simplify, I have 7x. Negative 9 times 3 is going to be negative 27. Equals 29. I need to get rid of minus 27 by adding 27 on both sides. When I do that, negative 27 plus 27 is going to cancel. So I get 7x equals 29 plus 27. Well, I know 20 plus 20 is 40, and 9 plus 7 is 16, so 40 plus 16 is going to be 56. To get the x by itself, I can divide both sides by 7. So I end up with x equals 56 divided by 7, which is 8. So the solution to this system of equations is going to be the point 8 for x, make sure you get the order right, and 3 for y. Moving on to number 4. First off, I need to pick a variable to eliminate. So in the previous ones I was eliminating x, but if I take a look at this, in front my coefficients of x are positive 5 and negative 10. 5 and 10 are not the same number even though they do have different signs, therefore they're not going to eliminate. But if I take a look at my y's, I've got negative 9y and positive 9y. So in this case, I'm going to be eliminating y, which we are totally allowed to do. So negative 9y plus 9y is going to cross out, they'll eliminate. 5x minus 10x is going to be negative 5x. And negative 5 plus 10 is going to be positive 5. So in order to get this x by itself, I'll divide both sides by negative 5. Negative 5 divided by negative 5 will cancel on the left side. So I'm left with x equals 5 divided by negative 5, which is going to be negative 1. So now I can take this negative 1 and plug it in for x this time into my top or bottom equation in order to solve for y. I'm going to do the top. Again, it certainly doesn't matter. In fact, if you would like to check your work, I recommend plugging it into the top and the bottom just to be sure that you're getting it correct. So for my top equation, I've got 5. Instead of x, I'm plugging in negative 1. And then minus 9y equals negative 5. If I go through with the simplifying process, 5 times negative 1 is going to be negative 5. And then I'll bring down the minus 9y and the negative 5. I need to get rid of minus 5 at this point, so I'll add 5 to both sides. When I do that, 5's cancel on the left, so I'm left with negative 9y equals negative 5 plus 5, which is 0. So now what I can do is divide both sides by negative 9 to get the y isolated, or by itself. Negative 9's cancel on the left side, so I end up with y equals 0 divided by negative 9, which is going to be 0. So the solution to this system of equations is going to be the point negative 1, 0. Okay, only 2 left. You're doing great so far. If you need to pause the video because you need more time, feel free to do so. I'll be here when you get back. So taking a look at my next system of equations, okay, I need to pick a variable to eliminate. For my x's, I've got a positive 8 as the coefficient and a negative 3. Those are not the same number with different signs, so they're not going to eliminate. But if I take a look at my y's, I've got positive 5 and negative 5. Therefore, in this situation, my y's are going to eliminate. So 5y minus 5y cancels, and I'm left with 8x minus 3x, which is 5x, equals negative 17 plus 22, which is a positive 5. Now to get the x by itself, I can divide both sides by 5. 5's cancel on the left side, so I'm left with x equals 5 divided by 5, which is positive 1. So now I can pick the top or bottom equation. I'll do the top this time. So for my top equation, I've got 8, but instead of x, I now know that it is 1 plus 5y equals negative 17. 8 times 1 is going to be 8. And then I'll bring down the plus 5y, the equal sign, and the negative 17. At this point, I can get rid of this positive 8 by subtracting 8 on both sides. When I do that, 8 minus 8 cancels on the left side. So I am left with positive 5y on the left, my equal sign, and negative 17 minus 8 is negative 25. My last step will be to isolate y by dividing by 5 on both sides. 5's are gone on the left side, and I am left with y equals negative 25 divided by 5, which is negative 5. So the solution to this system of equations is the ordered pair 1, negative 5. Awesome. One more problem. Then it'll be your turn to practice. Okay, so for this system, I've got 4x plus 9y equals 12, and negative 4x minus 7y equals negative 4. So we have to pick a variable to eliminate, as always. That'll always be our first step for the elimination method. If I take a look at my coefficients of x, I've got positive 4 and negative 4. That's good news because they are 4 and 4 are the same number, but they have different signs. The top one's positive, bottom one's negative. At this point, I can eliminate the x's. 9y minus 7y is going to be a positive 2y. And 12 minus 4 is going to be positive 8. So to isolate that y, I need to divide both sides by 2. 2's cancel on the left side. So I end up with y equals 8 divided by 2, which we know is 4. So now what I'm going to do is pick the top or bottom equation. How about this time, let's do the bottom equation, just for fun. So for the bottom equation, I've got negative 4x minus 7, but in place of y, I now know what it is. It is 4, so I'm going to plug in the 4 equals negative 4. If I keep simplifying, negative 4x I haven't touched yet. Negative 7 times positive 4 is going to be negative 28. Bring down my equal sign and my negative 4. At this point, I need to get rid of that minus 28 by adding 28 to both sides. And I do that, negative 28 plus 28 cancels on the left side, so I'm left with negative 4x equals negative 4 plus 28, which is going to be positive 24. I can now divide both sides by negative 4 to get that x isolated. Negative 4's will cancel on the left, so I get x equals 24 divided by negative 4, which is negative 6. So the solution of this system of equations is going to be the point, be careful with the order here, negative 6, positive 4. That does it for this video for elimination without any scaling. If you have any questions, please come see me or send me an email. Good luck on your practice. Have a good day.